Assalamualaikum warahmatullahi wabarakatuh. My name is ULFA SYAZWIN binti Muhammad Sahabuddin. My matrix number is P0920104112. Today I will be explaining the ship selection for this assignment. The ship selection for this assignment is a tanker ship. Tanker ship is a vessel that facilitates the supplying of mass quantities of liquefied freight. Liquefied goods can include both rock oil extracted from underneath the earth and any other sort of liquid goods, such as alcoholic beverage, hydrogen-based organic molecules, chemicals, and even juice. They can also transport liquefied gases compounds. These tankers are equipped with the latest technology and come in a variety of sizes and capacities. The size range from small self-propelled barge to extremely massive petroleum transports. And lastly, tankers make up around 30% of all commercial ships in the globe. At the right side, we can see that the first picture is the actual tanker ship, while the second one is the drawing of cross-section area of tanker ship.
Assalamualaikum warahmatullahi wabarakatuh. My name is ASYRAF bin KHALID. So I will present about the cross-sectional area of the ship. The cross-sectional area is the area of the ship's hull when viewed from a perpendicular angle, usually taken at a certain point along the length of the ships. This cross-sectional area can determine the characteristic of the ship, such as displacement, buoyancy, and hydrodynamic resistance of the vessels. In this assignment, the cross-sectional area of the ships will be calculated by using the Simpson first rule. As you can see in the picture, that is the example of the Simpson first rule, where the cross-sectional area will be calculated. The cross-sectional area of the ship's hull in this assignment will be calculated under three types of loading condition, that is light ship, loaded, and ballast. Next, the picture shows here are the cross-sectional area of the ship that had been sketched under three types of the loading condition, that is light ship, loaded, and ballast. And these sketches are important for the calculation where it has a specific information such as the length of the ordinate. Under three types of the loading condition, it has a specific information such as weight, draft, breadth, half breadth, length, and interval. And all of the information are also used for the calculation. After the cross-sectional area of the ships had been calculated under three types of the loading condition by using the Simpson first rule, the total area for the light ship will be 12,308.16 meters square. The total area for the loaded will be 12,645.6 meters square, and for the ballast loading condition will be 12,592.8 meters square.
This is the calculation for the volume of the ship. The cross-sectional area for the tanker ship is triangle. The formula that we use to calculate the volume is V equal to 1/2 times length times breadth times draft. We will calculate the volume for light ship, loaded, and ballast. For light ship, we get the volume 163440 meter cube. For loaded, we get 233067.6 meter cube, and lastly for ballast, 201583.2 meter cube.
Assalamualaikum, my name is Muhammad FIKRI bin NAHAR. My matrix number is B0920101144. Now I'm going to discuss about the longitudinal moment of three different conditions. The first is light ship condition. We use the formula of KB equals to half of draft, and then we got 11.35 meter. And then we calculate the triangular BM using the formula B squared over 6D. We got 47 meter for this light ship condition, and then the half breadth from waterline, which is kg, is 19 meter. So we calculate the km, which is kb plus bm, and then we got 58.35 meter. After that, we calculate the gm, which is km minus kg, which is 39.35 meter. And then by using the weight and kg, we calculate the moment about the keels, and we find the final kg, which is 21.05 meter, and the final gm, which is minus kg final. We got 37.31 meter. After that, we find the listing moment of starboard and port. We got the listing moment which is 1,525,810. And then after that, we calculate the listing moment in degree, which is 16.84 degree. We continue to calculate the listing moment of the loaded condition and the ballast condition using the same step. And we got the listing moment of the loaded condition is 1,543,100. While in the degree is 18.70 degree. Continue to the ballast condition. Ballast condition have the listing moment of 1,535,801. And in the degree, we got 18.45 degree.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish ADLI bin Muhammad NAZRUL, and now I will continue to the second moment of inertia. So the second moment of inertia involve the value of LCFMS, TCFCL, IMS, and ICL. So firstly, we must do the Simpson first rule because all the information needed to do the calculation based on the Simpson first rule. So for the example here, we have the submission of error product, submission of FMMS product, submission of IMS product, and the submission of ICL product. So this information is required to do the calculation. So here, this is the formula for the calculation. So the first formula is AW. So the AW 2HL divided by 3 and times by the area of the product, LCFMS 2HL divided by 3 and times by FMMS product and divided by the AW. The third formula is IMS 2HL divided by 3 and times by IMS product, ICL 2HL divided by 3 and times by the submission of ICL product. Lastly, the TCFCL 0 divided by AW. So the value of HL is different based on the condition, like ship, but loaded and ballast. So just insert the formula from the Simpson, from the information from the Simpson rule. So this is our calculation for three different conditions, which is like ship, loaded, and ballast. We just insert the formula from the previous slide and get the value from the Simpson first rule table.
Assalamualaikum. My name is Muhammad Nur Aiman bin ZAMZANI. My matrix number is B0920100061. Now, I will continue to the initial stability. So, in all three conditions of the tanker ship, which are light ship condition, loaded condition, and ballast condition, we can compare the values of metacentric height, or we call it as GM, with the ship's center of gravity, which is kg, to assess the ship's stability. So, as we all know, if the metacentric height, which is GM, is less than the ship's center of gravity, it indicates an unstable condition. The center of buoyancy is located below the center of gravity, creating a destabilizing moment when the ship heel or roll. This configuration can lead to potential stability issue and should be avoided. Besides, when GM and KG are equal, the ship is in a neutral stability condition. The center of buoyancy coincide with the center of gravity, resulting in no restoring moment. Any inclination or disturbance will neither increase nor decrease the stability of the ship. As we can see, the value of metacentric height for all three conditions are greater than the ship's center of gravity. So, in this case, it indicates a positive stability condition. The ship's center of buoyancy is located above the center of gravity, creating a restoring moment when the ship hills or roll. This configuration enhance the ship's stability. Next, we move to the intake stability. First, we need to calculate the rating level or GZ curve for each loading condition to analyze the intake stability of the ship. So, if we want to find the value of rating level, we need to use the formula of GM times with sine theta. So after we get the values for each loading condition, we can make a stability curve to find a maximum rating level. So the highest point on the GZ curve, known as the maximum rating level, indicates the angle of heel at which the ship experience its greatest restoring moment and stability. The greatest rating level enhance the ship's initial stability. It demonstrates the ship's capacity to withstand capsizing while maintaining an upright position in despite external force.
Lastly, the design justification for the ship design. The main objective of the IMO is to make all types of shipping, including tankers, are safe to use. The precautions outlined in the numerous safety conventions and guidelines apply to these and other ships. And the safer a ship is, the less likely it is to be involved in an accident. For this assignment, the ship design must follow the requirement that been stated in the IMO. This will make sure the ship design is safe to use to transport liquefied goods. It can also help to ensure the safety for the crews on the ship and also prevent unwanted scenario while handling the ship.